Hi, we are the group for the PLC 247. Here we have connected for this presentation new elements. These new elements are electropneumatic elements. These elements work with pressure air. So for this we have first to supply of energy the relays of the electropneumatic elements. These three are there are three relays, and we have the source from the PLC or PLC from Alen-Bradley have a converter that gives you the option to get 24 VDC. Then we have to connect this 24 VDC to our digital output relay. Yes, so we get here the power, we get it out and connected to the digital input of the relays for the power. Then we connect the inputs of our three relays of the electropneumatic elements, and we close the circuit with the common wire that comes again to the source of the PLC. Then these elements work with these two valves are for our control. This valve regulates the pressure air. We have a regulate for 0.2 megapascals, and this one allows the go through of the air into the system. So right now we have the system supplied with air pressure. So now we will show you how this works. Our plant is working, as have you seen here, and these elements are connected to different elements of the simulation in Factorio. This one is connected to the graph. This relay is connected to the move X, and this one is connected to move C. And now you can see here how it works in the Factorio. And can you also hear the sounds of how the valves are working?
In the communication architecture, we have three main components, which are Telegram bot, Node-RED, and the PLC. The user initiates interaction with the system through the chat of the Telegram bot, which can be operated remotely from a mobile device such as cell phone or computer. The bot reads the user commands and orders and sends them to Node-RED, which translates them into signals that PLC receives via the internet. All the parts are interconnected and feed of each other, so the PLC receives information from Node-RED and Node-RED receives information from PLC, depending on the user requirements.
We have this Telegram receiver node, where we receive all the message that is sent to our bot. Then this message is evaluated in this function interface. In these functions, we set and the flow variables, the chat ID and the message ID of every message sent to the bot. We also change the content of the message to lowercase. After we have the message in lowercase, we evaluate it then in this switch. In this switch, we see if the message is a hello message, or in this hello function, we only send a photo with a link and a caption saying hello to the user. In this function, digital twin info, we send, depending on if the word is escena or hoja, an image of the escena in where we are simulating the digital twin of the plant, or the data sheet of our motor. In this function, system status print, we print the sensors and actuators state in the plant. We also send a message with the a state of the model. It could be automatic or manual, and of the state in the plant. This refers if the plant is energized or not, or if it is producing or stopped. Finally, we have a function called buttons that are the actuators that we can activate from the bot. Those are buttons that simulate the energizing and the starting of production of the plant. After we create the message, we go to these little functions when we send a message of the state of the plant fully, and here when we start the code of the buttons to the Telegram. Finally, we send all this information to the Telegram sender as is shown in the chat. Here we have this node. There is the connection with the Rodwell PLC in this IP. We get the tags that we want to analyze, that are all of these. And here we save all this information as a collection in all the variables in our flow. After we have the message in our bot buttons, we come to the switch. Here we evaluate which of the actuators we have to activate or deactivate, as you can see. Then we set a trigger with a value true for 1 second and then false to our PLC through this function that are related with a single tag or ladder code. We can see here in our ladder code where we receive all the tags that we are expecting from the node red. And as we can see, we have a little restriction here where we decide if we can activate it or not, depending if the plant is in manual or automatic mode. This mode is changing here in our factory view model.
We can connect to the bot through a QR code that redirects us directly to the chat of the bot. In our case called PLC Estrellitas 247, when we press start and greet the bot, we can see the interface.
As you can see here in the screen, we have our bot in Telegram, and we have also our plan in Factory IO. This is our eScene. So first, we can say hello to the bot, and our bot will respond. Will answer us. So this is the message of welcome. So after that, we can select one option here in our keyboard. We can see our buttons. For example, we can see the mode of the plant. So like you can see here, right now our automatic mode is turned off. So if we change here, we can try again, and you can see our mode is the other. So also we can look in Hoja, like the data sheet of our motor. We can here pick escena for see our factory IO scene, and we can start clicking here. So when we click start, we can give energy to our system. Okay, so we can see here our plant. So we pick start. After that, we can pick the option on here in our keyboard. So you can see the motor running. We can see also our actuators, our pneumatic cylinders, and we can see here the simulation like Lewis working at the same time. For example, we can put off. So our plant will stop. You can see the plant stop, but we can see, for example, the state of our sensors. So we can put on again for see the sensors when are changing again. Okay, so for example, the actuators. So you can see what conveyors, what clamps are working in that moment. So we can put here off or look the sensors again. So you can see the sensors are changing. Likewise, the actuators. We can put turn off our plant. So after one cycle, the plant is off. After that, we can stop. So we don't have energy right now in our plant. So that's the finish of the process.